Hello students, so Miss Tracy goofed, and when I was setting up the Algebra 2 for this semester, I did not include the calendar post that you needed for your geometry review that introduces how to find the area of the sector of a circle. I have posted it for you now. You should have access to it all week to be able to go into the calendar and pull it up, and it's just 2 videos that gives you a review of some of the basic geometry we learned in Algebra 1. And it also includes a few finer points that just kind of it takes what you've learned and kind of applies it. And one of those things that it applies it to is the area of a sector. So to find the area of a sector, and I don't know what this is doing, when you find the area of a sector, all you're doing is, when you have a circle, a sector, that is not a circle. Hello. All right, this is going to be a circle. When you have a sector of a circle, it looks like, kind of looks like a piece of pie or a piece of pizza, right? It's going to be one part, or it's going to be a fraction of that circle. Now, a whole circle is 360 degrees. So when you are given the degrees of this angle here, we know that the sector is going to be a fractional part that represents the degrees out of 360 degrees. So for a sector, this is a sector of a circle right here that's 40 degrees. For this sector, we can say that is going to be 40 degrees out of 360 degrees because the whole circle is 360 degrees. But we only want to find the area that is for the 40 degree part. So that's what we have here. You take this right here, 40 out of 360, and you reduce that as a fraction to 1/9. You always want to reduce it if you can because then it makes your math easier to do. That's always what you want to do with a fraction when you can. So we know that this sector right here is going to be 1/9 of the whole circle. So that's what we're going to use to find the area of this part. So we're going to break it into 2 parts. We have the area here that is a sector, and then we have a triangle here. So we have the sector of a circle, and then we have a triangle. So we already have learned that this area is 1/9 of the circle. And we need to figure out what the dimensions of this triangle are. Now we can't use 5 because 5 is not, it's a base, but it's not a height. And we can't use this as a height because it's a slopey side. But what I do see is that this is a 90-degree angle, which means that this is a hypotenuse. So we don't want to use the hypotenuse side anyway. But one of the things that I know about a circle is that this is a radius. And if this is a radius, if this is a sector, this is a radius, and this is a radius. So that means this dimension and this dimension are going to be the same. So now I have a triangle with sides 3 and 4 in length. So I can find the area of this triangle using that. So let's find the area of the triangle. We know to find the area of the triangle, it's going to be 3 centimeters here times 4 centimeters, because this is the base and this is the height, and you divide that by 2. 3 times 4 is 12, divided by 2 is 6. So that's 6 centimeters square. So this area is 6 centimeters square. Now I need to find this area. So we know the area of a circle, right, is equal to pi r squared. So in this case, we've got pi, and then r squared is 4 centimeters. That's the radius. So 4 centimeters squared. Pi times 4 centimeters squared. But we also know that we only want 1/9 of the circle area. We just want a part of it, 1/9 of it. So we're going to multiply the total area by 1/9 to find that part of the area for that sector. That's all you're doing differently for the area of the circle. You are just taking this and making it a fraction so that you know what to multiply to tell what part of that total area you're talking about. And in this case, we are talking about 1/9 of the whole circle, which is 40 degrees. So this is how you would do that. You would just put 1/9 in front and do your calculations like normal. So 4 times 4, because this is squared, would be 16. So I want 1/9 of 16 pi centimeters square. And to multiply a fraction times a whole number, we know we just put the whole number over 1 and multiply straight across. So this would equal 16 pi over 9 in centimeters square is our unit of measure. So now all I have to do to find the total area of both of these is add them together. So I'm going to do that. I'm going to say 6 plus 16 pi over 9, and that's going to be in centimeters square. That is the area for this whole pink shape because we've added this together. So that's what that is. Let me move this right here. Oops. It's not going to let me. This is that dimension for the whole thing. That is my area. You can leave it just like that. But that is not what we're looking for in the problem. In the problem, it says, what is the volume of the cone? And it's 12 centimeters tall. So now we have to take this is the area of the base, and turn it into a cone 12 centimeters tall. So the volume of a cone is equal to the area of the base times the height divided by 3. So that's what we're going to do. We're going to drop in the area of the base, which is 6 plus 16 pi divided by 9 times the height, and that's centimeters square, times the height of 12 centimeters. It tells us right here it's 12 centimeters tall. And then all of that is divided by 3, if I can draw a straight line. All of that is going to be divided by 3. So I'm going to reduce this fraction by reducing this right here. This is 12 is 4 times 3, so I'm going to take 3 as a factor. 4 times 3 is 12. So I'm going to cancel this and this to reduce it. So now I have 6 plus 16 pi over 9 centimeters square times 4 centimeters. That's so much easier to do than having to divide later. So now I can just straight multiply and be done with it. 4 times 6 is 24, plus 16 times 4 is going to be 64 pi over 9. Centimeters squared times centimeters is centimeters cubed. This is the answer. That is the answer for the volume of a cone with this area as the base. That is 12 centimeters tall. Okay? So just think about when you're looking for a sector of a circle. The whole circle is 360 degrees. You're just going to write a fraction that tells me the degree of the sector, 40, out of the whole circle, which is 360, and then reduce that to a fraction. Then you're going to take that fraction and put it in front of the same formula we've been using for area of a circle since the beginning of time, just so you can find the proper number that is corresponding to that. All right? It's like if you were to take, oh, I have $10. And I want to give my friend half of $10, right? That'd be 10 over 2. That'd be 5. It works. You want to give them half? You write the fraction for half, and then you multiply. That's all we're doing for the sector. We're finding the fraction of the circle that we want by using the degrees, 40 over 360, to give us the fraction of the circle we're looking for. Then we multiply that fraction times the total area of the circle. That gives us our answer. Okay? That's how you have to think about it. You already know how to do it because you already know how to find a fraction of a number through multiplication, or how to divide through multiplication, or how to find part of something through this process here. It's the same thing we've been doing for a very long time, only now we are applying it to part of a circle. Okay, so it's not really brand new, it's just a brand new application. But it's entirely within your skill set to be able to do. All right? So I expect good things. So this is the answer. Now, some of you may have converted that to a decimal by using pi. I think I allowed that for this problem because this is very complex looking and it doesn't resolve to a whole number here. It doesn't matter. All of that is an acceptable answer in the system, and it is doable. You have the skill set necessary. You just have to be able to perceive the steps that you need to apply. All right, that's all I have. Tracy out.